I'm going to talk about the basics of Java static code analysis. What are static code analysis and why we need such tools? And we are going to talk about what are the available static code analysis tools. Finally, I'll be doing a practical demonstration using Spring Boot Gradle application. As developers, we are bound to make mistakes when we are developing large-scale software systems. Here we are talking about the issues or mistakes that doesn't captured by the Java compiler. Compiler doesn't catch errors like code styling, coding standards, best practices, patterns, and etc. For this purpose, we have the static code analysis tools. Static code analysis will check the errors before the execution. And obviously, there's another category called dynamic code analysis, which will evaluate the code during the execution time. In this video, we are not going to talk about the dynamic code analysis. Here, I'll be talking about three major tools available today. First one is called PMD. This will check potential problems like naming conventions, unused codes, code complexity. Second one is check style. This will check coding standards and code conventions. This will follow various coding conventions available today like Sun code convention, Google Java styling that we can configure in our project. Third one is find bugs. Especially this will look for bugs in Java code. It checks for bad practices, malicious code, vulnerabilities, multi-threaded related issues, performance and security issues. And that's the basic description of static code analyzing. So let's move into the practical demonstration. For the practical, I'll be using Spring Tool Suite IDE, but you can use any tools like NetBeans, Eclipse, or anything like that. So I'll create a Spring Boot start application first. Here we'll select the Gradle build sheet 3, which is the latest, and the rest we can leave as default. Okay, now you can see our project. The basic project was created in here. There we have our main Spring Boot class file, and we will be having a single test file for this, and we have the build.gradle file where our Gradle configurations are available. Okay, so first let's try to build this project and see what will happen. You can install Gradle in your operating system. If it is Mac, you can install it through the homebrew itself. So I have installed Gradle 6.0, which is the latest. Let's cd into the project and do a Gradle clean build. This will build our project with all its dependencies. Remember, still I didn't integrate or configured static code analysis into my project. Okay, now you can see it's build successful. You will be able to see a build folder under your project. If you can't see it in STS, you can go to the filters and remove the Gradle build folder, check in here. Now you can see the build folder, and if you go to the reports, you can see only the default test report. Okay, now let's integrate the static code analysis into our project. There are a set of Gradle plugins that we can use for this, so let's include them in here. So I'm going to add the Spotbox plugin. You should remember this Spotbox is nothing but the same Findbox that we had before. In Gradle 6 or later versions, Findbox plugin is not available. So instead they have given the extended version of Findbox called Spotbox that we can use in our project. Let's apply the other plugins as well. Check style, PMD. So we have included our plugins. Now let's add the configurations. First I'm going to add the configuration for the Spotbox. There are a set of properties available for the configurations that you can find it in the official websites, or if you Google it you can find them. But there are set of common properties that we are using in our industrial projects. So let's add those. Ignore failures. This will continue the build even if there was a static code analysis issue. If you set it default will be the false, which means the build will get failed if the static code analysis will have a problem. For progress, this will show a log of the current execution, effort, max, and report level is high. This is important, where you can select whether it's high or medium or low. That's all in the Spotbox configuration. So let's configure the PMD. It also has set of predefined properties, so I'm adding them now. So this property, PMD test enabled, if you set it as false it will ignore the JUnit test cases. And finally we have to give a array of rule sets in here. These rule sets can be found in the official code location. I'll add this link in my blog post. Here you can see all the available core rule sets for the PMD. I'm not going to talk in detail about each of these, but I have selected a set of common rule sets that we are using in our projects. So I'll add them, and that's all the configuration for PMD. For the check style, we should be having a configuration file. I'll describe this in a bit. Then here also we can do ignore failure, so the build won't fail if there is any check style error. Okay, so this configuration file details can be found in the official website, so I'll add that link also in my blog post. If you go there, you can see a set of rules or modules available for the check style, and there will be set of conventions as I mentioned earlier: Google code style, Sun code style, and check style default one. You can select either one of them. I have selected set of rules for my project, so it can be differ for the purpose that you have. Let's create an XML file. I'm naming it as checkstyle.xml. Okay, and I'm pasting the rules that I have identified. So if I just do a walkthrough on this, so here I have added the rules to check redundant imports, unused imports, and to check the constant naming conventions. Like for example, if you add a static variable, it should have the name should have only the caps. Name should be in caps, and the method name conventions, package name conventions, empty block, likewise. You can select the configuration as you wish. So this file path we have to give under the check style job as shown in here. Okay, now we have done the configurations. Now we have to set the execution points for these. So for the spot bugs, we have to set the spot bugs main. Here we can define which type of reports that we have to generate for the project. Mainly we have two types of reports available. One is XML and the other one is HTML. You also can integrate SonarQube into your project to track the static code analyzer reports. If you want XML reports, you can set it true. If you don't want, you can set it false. And for the HTML also same. And that's for the spot bugs. And for the PMD, we can set the tasks, the type, here also the reports will be having the same properties, so you can enable or disable as you wish. And these are the basic configurations that we have to follow if we want to integrate static code analysis into our Gradle project. Okay, now let's create a sample class. So in here I am having some unused variables bc and with invalid variable types, and I'm having invalid method names, and lengthy method names. All these will get validated by our static code analysis integration. Okay, now let me rerun the Gradle build. In the logs you can see the errors that are available in our project that were captured by the static code analysis. Since I have set ignore failure true, so build will get successful, but there are issues in our project. So let's see the reports. If you go into the build folder, you can see the generated reports for the static code analysis. Let me evaluate it. Okay, first let me go through the check style. Here you can see the check style errors. It shows the class name, file name, and what is the error. If you click on this, you can see what was the actual issue. It says the pattern is invalid. So likewise you can resolve those issues and do the build again. So this has generated a report for our test cases as well, but still we can ignore the generation of the reports for the JUnit test cases. As you can see, since we have added the both, we have enabled both XML and HTML reports. You can see two reports are generated for each case. Let me open one of the XML file and show. Yeah, you can see the same detail we added in the XML as well. So these reports can be used to further analysis using SonarQube or any other graphical integrations. So that's optional case. And if you go to the PMD, you can see the PMD issues. You can see the file and the line number and what is the problem. And if you click on this problem case, it will redirect to the PMD official page and will give a detailed information about the issue and how you can resolve this issue. And finally, if you go to the spot bugs, you can see the spot bugs or find bugs errors. Here you can see the summary of the available errors in your project. And that's about the demonstration. If you have any questions, please leave a comment in my blog post. I'll add this sample project, link of this sample project in my blog post so you can refer to it. Have a great day. Cheers.